While a single meter combining GFCI trip testing and milliamp leakage testing might be difficult to find today, separate dedicated testers are readily available and can provide equivalent functionality. Ideal Industries offers two such tools, the 61.52 GFCI tester and the 61.55 milliamp leakage tester. The 61.52 GFCI tester is designed specifically to test the trip functionality of ground fault circuit interrupters. GFCIs are crucial safety devices that protect against electrical shock by monitoring the current balance between the hot and neutral conductors. If a difference in current, indicating a leakage to ground, exceeds a certain threshold, typically 5 milliamperes, the GFCI will trip, interrupting the circuit and preventing a potential shock. The 61.52 GFCI tester simulates this ground fault condition, allowing you to verify that the GFCI is functioning correctly and tripping within the specified time and current limits. To use a GFCI tester like the 61.52, you would typically plug it into a receptacle protected by the GFCI you want to test. The tester has a button or switch that initiates a ground fault simulation. When activated, the tester introduces a small current imbalance mimicking a leakage to ground. The GFCI should trip almost instantaneously. The tester will indicate whether the GFCI tripped successfully. Some GFCI testers also provide information on the trip time, allowing you to assess whether the GFCI is tripping within the manufacturer's specifications. Regular testing of GFCIs is recommended to ensure their continued effectiveness. It is important to note that GFCI testers are designed to test the tripping function of the GFCI itself. They do not measure the actual leakage current in a circuit or piece of equipment. For measuring leakage current, a separate milliamp leakage tester is required, such as the Ideal Industries 61.55. The 61.55 milliamp leakage tester is designed to measure small amounts of current leakage to ground. This leakage current, even if below the GFCI trip threshold, can indicate insulation breakdown, wiring faults, or other electrical problems. Measuring leakage current can be helpful in troubleshooting electrical equipment, identifying potential safety hazards, and preventing equipment failures. To use a milliamp leakage tester like the 61.55, you would typically connect it in series with the equipment under test. This means that all current flowing to the equipment must pass through the tester. The tester then measures the current flowing to ground. The reading on the tester indicates the amount of leakage current in milliamperes. Interpreting the leakage current reading requires an understanding of acceptable leakage current levels for different types of equipment. Generally, lower leakage current is better, indicating a healthier electrical system. High leakage current may indicate a problem that needs to be addressed. For example, in the case of the pool pump mentioned, a milliamp leakage tester can help identify excessive leakage current, which could be a safety hazard or indicate a failing pump motor. By measuring the leakage current, you can determine if the pump is within acceptable limits or if it needs to be repaired or replaced. When using a milliamp leakage tester, it is important to follow the manufacturer's instructions carefully and to take appropriate safety precautions. Electrical safety is paramount, and it is essential to use the tester in a safe and controlled manner. It's also important to differentiate between normal leakage current and fault current. Normal leakage current is a small amount of current that is expected to flow to ground due to the capacitance of electrical equipment and wiring. Fault current, on the other hand, is an unintended current flow to ground caused by a short circuit or insulation failure. A milliamp leakage tester measures the total leakage current, including both normal and fault current. By comparing the measured leakage current to acceptable levels, you can determine if there is a fault present. Electrical codes and standards often specify maximum allowable leakage current levels for different types of equipment. These standards are designed to ensure electrical safety and prevent equipment failures. When troubleshooting electrical problems, it is helpful to consult these standards to determine acceptable leakage current levels. In addition to the Ideal Industries testers, other manufacturers also offer GFCI testers and milliamp leakage testers. These tools are widely available at electrical supply houses and online retailers. When selecting a GFCI tester or milliamp leakage tester, it is important to consider the features and specifications that are most important to you. Some testers offer additional features, such as the ability to measure voltage, current, and resistance. Others are designed for specific applications, such as testing GFCIs in outdoor locations. The accuracy and resolution of the tester are also important considerations. A more accurate tester will provide more reliable readings, while a higher resolution tester will be able to detect smaller amounts of leakage current. The price of the tester is also a factor to consider. GFCI testers and milliamp leakage testers range in price from a few dollars to several $100s. Choose a tester that meets your needs and budget. In summary, while a single meter combining both GFCI trip testing and milliamp leakage testing may not be readily available, separate dedicated testers like the Ideal Industries 61.52 and 61.55 provide equivalent functionality. These testers are valuable tools for ensuring electrical safety, troubleshooting electrical problems, and preventing equipment failures. Remember to always follow the manufacturer's instructions carefully and take appropriate safety precautions when working with electrical equipment. Regular testing and maintenance of electrical systems can help prevent accidents and ensure the continued safe and reliable operation of electrical equipment. When using these testers, understand that a GFCI tester simulates a ground fault to check the GFCI's tripping function. A milliamp leakage tester measures the current flowing to ground, helping identify potential insulation problems or wiring faults. These testers, used together, can provide a comprehensive assessment of electrical safety and performance. Moreover, consider the environment in which you will be using the tester. If you will be using it in wet or damp locations, choose a tester that is rated for outdoor use. If you will be using it in areas with high electrical noise, choose a tester that is shielded against interference. Also, think about the size and weight of the tester. A smaller and lighter tester will be easier to carry around and use in tight spaces. A larger and heavier tester may be more durable and have a longer battery life. Battery life is another important consideration. Choose a tester with a long battery life so you don't have to worry about running out of power in the middle of a job. Some testers use replaceable batteries, while others have rechargeable batteries. Consider which type of battery is more convenient for you. Display readability is also crucial. Look for a tester with a clear and easy to read display, even in bright sunlight or low light conditions. Some testers have backlit displays for improved visibility. The user interface should also be intuitive and easy to navigate. A complex and confusing user interface can make it difficult to use the tester effectively. Consider the safety features of the tester. Look for a tester that is UL listed or certified by another recognized safety organization. This indicates that the tester has been tested and meets safety standards. Also, make sure the tester has overload protection to prevent damage in case of accidental overloads. Finally, consider the warranty of the tester. A longer warranty indicates that the manufacturer has confidence in the quality of the tester. Read the warranty carefully to understand what is covered and what is not. Remember to always disconnect power before testing any electrical equipment. This is the most important safety precaution you can take. Also, wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical equipment, consult a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself. By following these guidelines, you can choose the right GFCI tester and milliamp leakage tester for your needs and use them safely and effectively to ensure electrical safety and troubleshoot electrical problems. And always remember to consult with the manufacturer's instructions for proper usage and safety guidelines. Understanding the basics of electrical theory and safety practices is essential for anyone working with electrical equipment. Education and training can help you avoid accidents and ensure that you are working safely and effectively. There are many resources available, including online courses, books, and apprenticeship programs. Taking the time to learn about electricity can save you time and money in the long run. Moreover, it is a good idea to keep your testers calibrated regularly. Calibration ensures that the tester is providing accurate readings. Over time, testers can drift out of calibration, leading to inaccurate results. Frequency of calibration depends on the type of tester and the frequency of use. Consult the manufacturer's instructions for recommended calibration intervals. Calibration services are available from many electrical supply houses and calibration laboratories. Regular calibration is an important part of maintaining the accuracy and reliability of your testers. Consider the overall cost of ownership when choosing a tester. The initial purchase price is only one factor to consider. You should also factor in the cost of batteries, calibration, and repairs. A cheaper tester may seem like a good deal at first, but it may end up costing you more in the long run if it requires frequent repairs or has a short lifespan. A more expensive tester may be a better investment in the long run if it is more durable and has a longer lifespan. Always remember that electrical safety is paramount. Never take shortcuts or cut corners when working with electricity. If you are not sure how to do something safely, consult a qualified electrician. It is better to be safe than sorry. Electricity is a powerful force, and it can be dangerous if not handled properly. By following these guidelines and taking appropriate precautions, you can work safely with electricity and avoid accidents. Keep in mind that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest codes and standards to ensure that you are complying with all applicable regulations. Electrical codes and standards are designed to protect people and property from electrical hazards. By following these codes and standards, you can help prevent accidents and ensure that electrical systems are safe and reliable. Finally, always remember to turn off the power before working on any electrical equipment. This is the most important safety precaution you can take. Even if you think the power is off, it is always a good idea to double check with the voltage tester. Never assume that the power is off. Always verify it with a tester. Working on live electrical equipment is extremely dangerous and can be fatal. By following these safety precautions, you can protect yourself from electrical shock and ensure that you are working safely. These testers are designed to identify and measure these risks, enabling you to take preventative measures and maintain a safe electrical environment.